Hi guys. In this lecture, we'll be discussing about the different types of fluids. So, as we've been already discussing about the flow characteristics, so we have two different methods in which the flow characteristics can be stated or a fluid flow can be stated, like a Lagrangian and an Euler method. So, as we already discussed, Lagrangian is studying a single particle that moves throughout the flow. Studying about that single particle is Lagrangian, where in an Euler method on a controlled volume when the fluid tends to flow at that particular point, what about the characteristics of a fluid we're going to study is a Euler method. So the next topic will be on the types of fluid flows. So there are different types of fluid flows: steady flow and unsteady flow, uniform and non-uniform flow, laminar and turbulent flow, compressible and incompressible flow, rotational and irrotational flow, 1, 2 and 3 dimensional flows. So let's discuss each and individual flow separately. The first is steady and unsteady flow. So the flow in which fluid characteristics like velocity, pressure, density at any point does not change with respect to time is known as a steady flow. So it means that we have a flow at any given point, the velocity does not change. Look at any given time. For example, this is starting time of you take this pipeline. So at this point, the velocity, for example, is 5 meter per second. At any given time, maybe at 10th second or at 15th second or at 20th second, if you check the flow, it will be same 5 meter per second. There won't be any change in velocity or pressure or density. Nothing will be changed. So it's called as a steady uniform flow. So unsteady flow, so that's why I call it as a change in velocity with respect to time is constant. Change in velocity with respect to time is constant. Change in pressure and change in density with respect to time is a constant, so it's equal to 0. So on an unsteady flow, the flow in which the fluid characteristics like velocity, pressure, density at any point changes with respect to time. So it keeps changing. So at this 10th second, the velocity might 5 meter per second. At 10th second, the velocity may be 15 meter per second. At 20th second, it might be 3 meter per second. It changes with respect to time. So it is not an uniform. Okay, so it called as a unsteady flow. So the next type is uniform and non-uniform flow. The flow in which velocity at any given time does not change with respect to space. So the length of direction of flow is known as uniform flow. So we have taken a straight pipe. So here it says that the flow in which velocity at any given time does not change with respect to space. So even at first meter, so for example, you have a 10 meters of a pipe. At second meter of the pipe, the velocity will be 10 meter per second. At fifth meter of the pipe, if you check, the velocity remains the same. And at 10th meter also it remains the same. It does not change with respect to the space, that is the length of direction of a flow. Okay, you call it as uniform. That means it is flowing uniformly. So there is a change in velocity with respect to space is 0 or constant. So on a non-uniform flow, the flow in which velocity at any given time changes with respect to space. So here we have a change in the cross section. So if there is a change in cross section, probably there will be some difference in velocity as well as the pressure. So at particularly at this example, at the starting, the velocity will be low and pressure will be high. So on a narrow passage, so you can have a higher velocity with low pressure. So velocity with respect to the space or length of direction changes with respect to the space. Okay, so it is not equal to 0, it is not constant. The next type is laminar and turbulent flow. The flow in which the adjacent layer do not cross to each other and move along the well-defined path is called as a laminar flow. So the name laminar denotes it's a lamin. Lamine in the sense layer by layer. Laminae, so layer by layer, so called as a laminar flow. So the flow moves in a layer by layer. So the adjacent layer and the layer next to it will not merge or will not cross over. Okay, so we call it as a laminar flow. So example here is given as a flow of blood in a small veins. It flows at a low velocity. So probably at low velocity we'll have a laminar flow. So further velocity increase, the flow becomes laminar to turbulent. So on a turbulent flow, the flow in which the adjacent layer crosses each other and do not move along the well-defined path is called as a turbulent flows. So here, so when you open it, water from a dam, it goes at a higher velocity. Okay, so it's a turbulent flows, or the turbulence which has been created from the airfoil of an aeroplane, the smoke that comes out from the chimney of a big industries, or the smoke from the cigarettes, or the smoke from the old trucks. So these are the few examples of a turbulent flow. So here you can see the flow is not flowing in a different path. Okay, so we call it as a turbulent flows. Next type is compressible and incompressible flow. The flow in which the density does not remain constant for the fluid flow is called as a compressible flows. So you can take a simple example of having a syringe. Okay, so you remove the needle, have a syringe. Okay, so it's been filled with the air. So if you push them, it can be compressed. Okay, so the volume kept changing. Okay, so it's a compressible fluids. So the flow can be compressed. So the flow, incompressible flow is the flow which cannot be compressed. Okay, so the flow in which the density is constant for the fluid flow is called as incompressible flows. So the density will not vary. Okay, so it's a constant. For a compressible, if you keep compressing the air, the density will keep increasing, because density equal to mass by volume. So volume decreases, automatically the density increases. Okay, where as we said earlier, density equal to mass by volume. Even the mass remains the same, if the volume gets reduced, probably the density get increased. Okay, so we call it as a compressible flows. So the next one is rotational flow and irrotational flows. On rotational flow, the flow in which the fluid particles while flowing along streamlines also rotate about their own axis is called as a rotational flows. So on a streamline, so when the water tends to flow on a streamline, it tends to rotate along its own axis. On based upon this axis, it tends to rotate about its own axis, called as a rotational flow. So irrotational flow, it does not rotate about its own axis. It does not rotate about its own axis, so it to be a irrotational flows. So these are next and final one is 1, 2 and 3 dimensional flows. So practically speaking, when the fluid tends to flow on any given cross section or any pipes, rivers or canals, it's a 3-dimensional flows. But for study purpose, it is very difficult to do it in a 3 dimensional. So for study purpose and for easier, we can take it as a 1 or 2 dimensional flows. So the 1-dimensional flow, the flow in which velocity is a function of time and one space coordinate x alone is considered is called as a 1-dimensional flows. So the change in velocity is a function of only one direction. Okay, so here it comes with the 2-dimensional is called as the 2 coordinates, x and y space. On the 3-dimensional, x, y, z, 3 will be considered. Okay, so these are the different types of fluid flows. So hope you guys have some idea about the different types of fluids. Thank you very much.